Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ZIKRY bin Muhammad ZAIDIE 281579 and I'm from Group 9 and we will do a forecasting on the chosen company that we have choose. From the assignment given, we need to do a forecast on the company that we have choose from 16 August until 5 November 2021, and the main objective is we need to forecast on 8 November 2021. In order to do the forecasting, we need to use 5 type of forecasting technique, which is weekly moving average, weighted weekly moving average, exponential smoothing, adjusted exponential smoothing, and linear trendline. And in order to improve our measure in forecast, the use of forecast accuracy has been implemented, which is mean square error, mean absolute percent error, mean absolute deviation, mean absolute percent deviation, cumulative error, and average error. Therefore, the chosen company that we have choose in order to complete this assignment is Sime Darby Bhd. Sime Darby Bhd is a Malaysian trading conglomerate company that involved in many different factors, which are motors, logistics, healthcare, industrial, plantation, property, and insurance. The first method in this forecasting is moving average. Moving average is a technique that is used to examine data points by calculating the average of the various subsets of the entire data set. This moving average also is a technical analysis in forecasting. By combining the price point of an instrument over a specified time frame or specified period that we have decided, we need to divide it by the number of the data points. The formula for this moving average is the sum of the data in period that we have choose, and we have to decide the periods. We need to divide it by the number of the periods in the moving average. So by referring to the slide, this is the forecast that we have done by using this weekly moving average technique. And the forecast for the 8 November 2021 is RM 2.245. As a result, from the forecast that we had done, we get all the forecast accuracy in order to improve our measure in this forecasting. So the mean absolute deviation that we get is 0.03071, and the mean absolute percent deviation, MAPD, we get 3.07%. The cumulative error we get 0.1665. The average error is 0.002972, and the mean square error is 0.002031, and the mean absolute percent error MAPE is 1.33%. From the graph that we have developed, we can see that the forecast line ran slowly to the actual price, and this is happening due to the longer period of time in forecasting. The next method in this forecasting technique is weighted moving average. The weighted moving average will place more emphasis on recent price than an older price, and this weighted moving average will follow the actual price more closely than we use the simple moving average. The assigning of the each weight is on the recent data, and the sum of all of the weight must be equal to 1, and the each period's data will be multiplied by a weight in order to get the forecast for the period that we have determined. The assigning of the weight in order for us to perform this weighted moving average technique have been assigned randomly, with the most recent data have a greater value than the past data, and the sum of all of the weight is equal to 1. Therefore, by referring to the slide, this is the forecast that we have done by using the weighted moving average technique, and the forecast for the 8 November 2021 that we get is RM 2.24. For the forecast accuracy that we get by using this weighted moving average technique is for the MAD, mean absolute deviation, we get 0.027. For the MAPD, we got 1.2%, and for the cumulative error, we got 0.126, and average error, we got 0.00225, and the mean square error, we got 0.001698, and for the MAPE, mean absolute percent error, we got 1.19%. The graph for this weighted moving average, by using the weighted value that we have decided, is also react slowly to the actual price, and in order to improve this, we can use the optimized weighted value, and to get the optimized weighted value, we can get it by the help of the Excel problem solver. So this is the new weighted value that we get by using the Excel problem solver. As a result, from using the new weighted value that has been optimized, we could see from the graph the forecast lines react well with the actual price, which means the optimized weighted value help us to improve our forecast. From all of this, we could see the weighted value is important in order for us to get a better forecast. So to determine the weighted value, we need to do it by trial and error experimentation, or we can get a help from the software such as this Excel by using the Excel problem solver.
Hello, my name is HAFZADEENA binti HASHIMI. My number matrix is 281512. So I'm going to present about the exponential smoothing. So the exponential smoothing is a time series data assigned to decrease weight for newest to the oldest observation. So here is the exponential smoothing formula. This is the exponential smoothing data that we have calculated based on the previous formula we provided. And here is the table from the 16 August to the 8 November. And we are using the forecast of alpha, which is 0.4, and alpha 0.2. Here is the exponential smoothing chart that based on the data that we have calculated. And here we can see the forecast using the highest smoothing constant, which is alpha 0.4, is react more strongly to change the price than those the forecast with the lower constant, which are alpha is 0.2. So here is the exponential smoothing data for the MAD, MAPD, MSE, MAPE, cumulative error, and average error. Based on the alpha 0.4 and alpha 0.2. From the previous table, here is a summary of the forecast accuracy. So we can see that the alpha 0.4 is the more accurate forecast. This is why the MAD for the alpha 0.4 is the smallest value, which makes it is the more accurate to forecast. Next is adjusted exponential smoothing. The adjusted exponential smoothing is the same like the previous exponential smoothing, but it is different because of the trend adjustment, which is either add in this formula. Here is the adjusted exponential smoothing data. We are collecting this data is based on the previous formula that we have shown from the previous slide. The difference is we are adding the exponential smoothing that from the alpha plus the trend, which is come from the beta that we are using, which are 0.5, and then we get the adjusted forecast. Here is the adjusted exponential smoothing chart. We can see the adjusted forecast is consistently higher than simple exponential smoothing forecast. This means it is more reflective of the generally increasing trend of data. Here is the adjusted exponential smoothing data for MAD, MAPD, MSE, MAPE, cumulative error, and average error. This is how we calculated like the previous exponential smoothing, but this time it is different because of the adjusted forecast. We are using beta here. So here is the summary of the forecast accuracy of adjusted exponential smoothing. So here we are comparing from the previous exponential smoothing and the adjusted forecast. So here we can see the adjusted forecast is the more accurate since the MAD of the adjusted forecast is the smallest value than the exponential smoothing. So the conclusion is the adjusted forecast is the more accurate than the exponential smoothing. So that's all from me. Thank you.
Hi, I am FADHLIN ADIBAH ZARIFAH binti ABDUL WAHID and my metric number is 281552, and I'll be explaining about the linear trend line. So linear trend line is one of the time series forecasting method. It is used by imposing a line of best fit to time series historical data. It also a simplistic forecasting that can be used to predict the demand. So when the data shows an obvious trend over the time, linear trend line can be used to forecast. However, a trend line does not change in trend, unlike the exponential smoothing. So these are the linear trend line equation, which is y equals to a plus bx, where a is the intercept at period 0, b is the slope of the line, x is the time period, and y is the forecast for demand for period x. What makes linear trend line difference is that for linear trend line, once we get the linear trend line equation, we can simply forecast for any period that we want. So for instance, if our data ends at period 56 and we want to forecast for period 60, we can simply substitute 60 into the linear trend line equation by substituting 60 into the x value. Next, these are the historical daily price data of Sime Darby Bhd, where we have the daily price data from 16th of August until the 5th of November. Then we need to assign each date as one period. So to solve for the equation, we need to assign the period as x and the daily price as y. Then we need to find the value of x times y and also x squared before solving the equation by using the formula. Once we have calculated the value by using the formula given, we will come out with a linear trend line equation. So for this example, the linear trend line equation for the Sime Darby Bhd is y equals to 2.269 plus 0.006x. So these are the linear trend line chart for the Sime Darby Bhd, where the blue line here is the daily price and the orange line is the linear line. So it can be seen that from the blue line, the daily data has some sort of random movements, where sometimes it goes up and then it goes down, and it also have the stay constant value. As mentioned before, once we get the linear trend line equation, we can simply substitute for any period that we want. So we would like to forecast for 8 November, which is the period of 57. So to forecast for this period, we need to substitute 57 into the linear trend line equation, where we will have y equals to 2.269 plus 0.006 times 57, and the forecast value for 8 November is 2.3032. Then we can create a linear trend line chart by using the daily data, which is the blue line here, and the forecast data, which is the orange line. So from the chart, it shows that the forecast data shows a trend line movement as it goes up. To check whether our forecast value is suitable or not, we are going to measure by using the forecast accuracy. So the aim of the forecast accuracy is to make sure that the forecast error to be as small as possible. So forecast error is actual values minus the forecast values. When the error is large, it indicates that the technique might be the wrong one or the parameter used need to be adjusted. So these are the calculation of the forecast accuracy for the linear trend line. So for the mean square error, MSE, it is 0.003, mean absolute percent error 1.93%, mean absolute deviation 0.0441, mean absolute percentage deviation 1.93%. So for linear trend line, there is no cumulative error and average error because the value is almost zero, and therefore it is not a good measure for this method. From all the forecast method where we have the weekly moving average, weighted weekly moving average, exponential smoothing, adjusted exponential smoothing, and the linear trend line, we will find one best method to be used to forecast. So in conclusion, based on the exponential smoothing, larger value of alpha is preferable. As we can see, when we use larger value of alpha, which is 0.4 as compared to 0.2, the forecast accuracy is much less than alpha 0.2, which makes it more preferable. Next, as compared to exponential smoothing and adjusted exponential smoothing, adjusted exponential smoothing forecast is more accurate than the exponential smoothing, because adjusted exponential smoothing where we add the trend element to the exponential smoothing forecast. So when we use alpha 0.4, which is the larger value of alpha just now, then beta is 0.5, the forecast accuracy is much less than the normal exponential smoothing, which makes it more accurate. So lastly, all in all, from all the method to forecast, we can conclude that the weighted weekly moving average forecast method is more accurate than other forecasts because the forecast accuracy is much lower than all other forecast methods. Therefore, to forecast for Sime Darby Bhd, it is advisable to use the weighted weekly moving average.